Assalamualaikum and good day everyone. Today we will learn about morphological image processing. This is the introduction part of morphological image processing. So we want to know what is morphology all about. When segmentation is complete, we have now the output of segmentation process, which are images in the form of binary, or we say binary images, which is 0 and 1. And now we can use morphological operations to remove the imperfections in this segmented image. In implementing the morphological operations, we need to know first what is the definition of morphology, and then what are structuring elements, and then what are hit, fit, and miss. As I mentioned in the last slide, that after segmentation we have done point detection or line detection, and then we proceed until thresholding, and therefore the final image is in form of binary image with 0 and 1. So in morphology we are concerned about 1, 0, black or white. Throughout all of the following slides, whether 0 and 1 refers to white or black is little interchangeable. All of the discussion that follows assumes segmentation has already taken place and that images are made of 0 for background, remember 0 for background pixels and 1 for object pixels. After this, it doesn't matter if 0 is black, white, yellow, green. So our uh, representation of the image is 0 for the background and 1 for the image pixel or for the object pixel. First of all, we like to know what is morphology. So morphological image processing or morphology are image processing techniques that deal with the shape or morphology of feature in an image. So we are concerning with the shape or morphology of the images. Morphological operations are commonly applied to remove imperfections introduced during segmentation, and so typically operate on bi-level images or binary images, same as which are the images we have after the segmentation process. These are some examples of thumbprints. On the left, image after segmentation. So you can see that there are white dots all over the image, and the right part, image after segmentation and after morphological processing. So we can see that the white dots have been removed. So this is some examples. This is one example which is similar to image restoration, but this is not about image restoration, but it's about morphology. So we are using morphological processing or morphological image processing to remove these imperfections. Structuring elements, or also known as SE, are blocks of pixels of any shapes and sizes. Here are examples of commonly used structure elements. On the top left here we have a square structuring element of 2 by 2 pixels. And next we have another square structuring element of 3 by 3 pixels, and then we have cross shapes structure elements, and below here we have some sort of diamond shape structure elements, and then we have a line shape structure element, which is in horizontal form, and then we have another line shape of structure elements in a vertical form. Okay, we now already learned what is structuring element, and here in the slide there is a structuring element of 2 by 2, which you can see here. Okay, now we want to know the second item or second element required in morphological image processing. So the term is fit. So what is fit? So fit occurs when all on pixels in the structuring element covers on pixels in the image. Okay, on the left here is the image. Okay, we will put the structuring element on the image, and this is to understand better what is all these terms. Okay, so as we all have learned that fit is when all on pixels in the structuring element covers on pixels in the image. Therefore, in the example of fit is when we put the structuring element on the position A. As you can see that every pixels in the structuring element covers the pixels on the image. So this part, this part, this pixels, and this pixel. Okay. Okay, now we will look at the next element or next situation, which is called hit. Hit is when any on pixels in the structuring element covers an on pixel in the image. So B is an example of a situation called hit, where only one pixels on the here is pixels on the structuring element, it match with pixels on the image. So one being covered by the structuring element, so this is hit. So we need at least one, can be two, can be three, but not all four. So if 1, 2, or 3 covered by the structuring element, this is called hit. And the last situation is miss. Miss is the simplest to understand, which is no on pixel in the structuring element covers any on pixels in the image. So example is when we put the structuring element on the location C, where none of the structuring element pixels cover any pixels of the object on the image, or any on pixels on the image. Okay, so we have now know what is structuring element, what is fit, what is hit, and what is miss. So all morphological processing operations make use these simple ideas. So we will later use all these elements and ideas again for implementation of morphological image processing. Now, if we relate these structuring elements with the shapes we just see, okay, we have seen just now. So the most left here, okay, the most left structuring element, as you can see here. So this is of square 3 by 3. Okay, the shape is square by 3 by 3. Okay, whereas the middle structuring element here, it is a square 3 by 3, but it's more likely it's more like a cross shape. Okay, cross shape, which we have seen before. Okay, and the last one on the most right here, we have a 5 by 5 structure element, and if you can see that it will make up a diamond shape of structuring element. Okay, now we will see more examples on hit, fit, and miss. Consider an image on the left. Okay, so here is the image, and consider two different structuring elements, which is structuring element 1 with all ones, and structuring element 2 is cross shape of 1. So let us apply structuring element 1 on this image. Now let us consider putting structuring element 1, okay, at different location. Okay. First of all, put structuring element 1 on A. So what is this? So if you can see that every one on the structuring element or SE, okay, covers one on the image. Okay, so everyone covers one. Okay, so what is this? So this is fit. Okay, okay, now what happened when we put structuring element 2 on the same location, which is on A? And we can see clearly that all one on the structuring element 2 covers all ones on the image. So this is also a fit. Okay. Now let us move the structuring element on to different location or position. Okay. What is the condition of structuring element 1 on B? So we can see that there is only, okay, there is one, okay, on the stretching element which doesn't cover, okay, 1 on the image. So we call this, of course, hit. But what if we replace the stretching element 1 with the stretching element SE2, with the stretching element 2? So we can see that still each of the one on stretching element 2 covers each one on the image. So this is still fit. Okay. So stretching element 2, SE2, have fit on A and also have fit on B. Okay, now let us move to a new location, which is C. So at location C, structuring element 1, okay, at a glance we know that there is only one on the structuring element on the SE1 which covers 1 on the image. So this is clearly a hit. But what is SE2 on C? So SE2 on C, we can check one by one. It seems that 1 here is 0 on the image, 1 here is 0 on the image, 1 here is 0 on the image, 1 SE2 0 image, 1 SE2 0 on image. So nothing hits or nothing's covered by 1 on the SE2. So we call this miss. And the last one is position D, which obviously we can see that it is missed by SE1, okay, and also missed by SE2. Okay. So miss for SE1 and miss for SE2.